136.8 degrees Celsius. That is the gap between the hottest and coldest temperatures measured on Earth this year, a wider range than the gap between freezing and boiling water. On Saturday, both ends of that range moved at once. Argentina logged the hottest night in 101 years of records, while a station in Antarctica produced the lowest air temperature measured on this planet since 2012. Same day, same hemisphere, and as it turns out, the same cause. By the end of this, you will understand exactly what connects them. 4 days ago, on Saturday the 18th of July, a thermometer on the East Antarctic plateau recorded a temperature of minus 84.1 degrees Celsius. That is minus 119.4 degrees Fahrenheit. It is the lowest air temperature measured anywhere on the surface of this planet since 2012. The reading came from Concordia Station, a joint French and Italian research base that sits more than 10,000 feet above sea level on the interior ice sheet. It is one of only 3 inland Antarctic stations occupied year-round, which means there are people there right now, in the middle of a 4-month night, watching the instruments do this. The figure came within roughly half a degree of Concordia's own all-time station record. That is not a small margin at the bottom of the temperature range. At those values, the atmosphere is scraping against a physical floor, and half a degree of additional cooling is genuinely difficult to produce. But the reading on its own is not the story. What makes this worth 20 minutes of your time is what happened on the same calendar day, 7,000 miles to the north, and the fact that the 2 events were produced by the same piece of atmospheric machinery. Almost nobody connected them, and the connection is the part that should concern you. Start with why that station is capable of producing a number like minus 84 in the first place, because the mechanism matters for everything that follows. Concordia sits high, and it sits dry. At more than 10,000 feet on the interior plateau, the air above it is thin. There is very little of it, and what there is contains almost no water vapor. Water vapor is the atmosphere's primary heat-trapping gas. Remove it, and you remove the blanket. Now add polar night. At Concordia's latitude, the sun does not rise for roughly 4 months of the year. There is no incoming solar energy at all. None. The surface radiates heat upward into space continuously, and nothing replaces it. Under those conditions, the temperature does not fall to some comfortable equilibrium. It falls, and keeps falling, toward the coldest value the surface of this planet is physically capable of producing. The only thing that can interrupt the process is warmer air arriving from somewhere else, and in June and July of this year, warmer air could not get in. That is the piece that turns a cold reading into a story about a system. Something was holding the door shut. It is worth noting what the recognized record actually is, because there is a confusing set of numbers in circulation. Satellite instruments have measured lower values than this on the East Antarctic plateau. Figures in the region of minus 93 to minus 98 degrees Celsius have been reported from orbit. Those are remote-sensed skin temperatures, meaning the temperature of the snow surface itself rather than the air above it, and they are not standard air temperature observations. They are real measurements of a real thing, but they are not what the record books track, and they are not what a station thermometer reports. Concordia's minus 84.1 is an air temperature, taken the conventional way, at a staffed station. On that same Saturday, the 18th of July, the city of Salta in northwestern Argentina recorded the hottest night in its instrumental history. The overnight minimum temperature never fell below 26 degrees Celsius. That is 78.8 degrees Fahrenheit. As an overnight low in winter, the climatological normal for that date in Salta is roughly 3 degrees Celsius. The reported anomaly was plus 23.2 degrees. I want to be precise about what that number means, because it is easy to skate past. 23 degrees Celsius above normal is not a warm night. It is a night that has no business existing in that record at all, and the record it appears in runs back to 1925. 101 years of observations from the Argentine National Weather Service. One caveat, stated plainly, because it matters. This figure reached us through a chart circulating online that was built on official Argentine National Weather Service data. The underlying data set is legitimate. The specific record claim has not yet been confirmed through an agency bulletin. Treat it as reported rather than as certified, and if a correction comes, we will carry it. There is also a reason a record overnight low is more revealing than a record daytime high, and it is not obvious. Daytime maximum temperatures are noisy. A break in the cloud, a shift in the wind, a dry air mass sliding over a valley, and a station can spike for an afternoon. Overnight minimums are different. To keep a city from cooling off all night, you need the whole air mass sitting on top of it to be warm through its depth, and you usually need humidity or cloud cover to stop the surface from radiating its heat away after dark. A record warm night is a statement about the state of the atmosphere over a region, not about one hot afternoon at one thermometer. That is why the Salta figure carries more weight than its raw number suggests. But hold the shape of this in your head. On one day, on one hemisphere, in one season. The coldest reading on Earth in 14 years, and the hottest night in a century of Argentine records. And they are not a coincidence. Here is the mechanism, and it is simpler than it sounds. There is a structure in the stratosphere over Antarctica called the polar vortex. Think of it as a lid, a ring of fast westerly winds encircling the continent, isolating the air trapped inside from the rest of the planet. When the lid holds, the air underneath it is cut off. No sunlight, because it is polar night. Almost no water vapor, because the air is thin and cold and dry. And no mixing with warmer mid-latitude air, because the ring of wind will not let it through. The trapped air radiates its heat to space and gets nothing back, and the temperature falls toward that physical floor I mentioned. That is exactly what happened at Concordia. When the lid breaks, everything reverses. Warm, moist air from the middle latitudes is pulled poleward. Cloud cover increases. The clouds radiate heat back down toward the surface. The coldest place on Earth starts running 30 degrees above normal. Same structure, two completely opposite outcomes. Which one you get depends entirely on whether the lid is intact. And it is worth understanding what actually holds the lid together, because that is where the fragility lives. The ring of wind is maintained by the temperature difference between the pole and the middle latitudes. The larger that contrast, the faster the winds, the tighter the seal. But the vortex is not sealed against everything. Enormous waves in the atmosphere, planetary waves, generated far away by mountain ranges, by the contrast between land and ocean, and by tropical thunderstorm activity, propagate upward into the stratosphere and break against it. Most of the time, the vortex absorbs them. Occasionally, when the wave activity is strong enough and arrives in the right configuration, it does not. In June and July of this year, the lid was not just intact. It was the strongest it has been in a long time. There is an index that measures this, and it hit a value that should stop you. The Antarctic Oscillation Index points. You will also see it written as the AAO, and it is closely related to what is more commonly called the Southern Annular Mode, surged to plus 5.0 in late June. Forecast guidance had it holding at plus 2 or stronger through the first third of July. Plus 5 is extreme. A strongly positive Antarctic oscillation is the signature of a vortex that is not merely present, but unusually tight, unusually fast, and unusually well organized. The lid was not just closed, it was sealed, and the effect on the continent underneath was enormous. Ensemble model guidance through that period showed most of the Antarctic continent, not a corner of it, most of it, running more than 20 degrees Celsius colder than normal. That is a continental scale cold anomaly. It was happening at the exact moment the Northern Hemisphere was running one of the most heat record-dense summers ever recorded, with more than 100 countries reporting record temperatures this year. And it gets stranger, because the vortex was not only doing something to Antarctica. The vortex has a position, not just a strength. This year, its core sat near and west of the Amundsen Sea. That specific location has a known downstream consequence. During the austral winter, a vortex core in that position historically induces a trough in the atmosphere off the central east coast of South America. That trough drives the wave pattern across the southern half of the continent, which means the temperature pattern over Argentina, Paraguay, and southern Brazil is being steered in part by the state of a wind structure over Antarctica. In late June, that configuration produced a cold pattern for Argentina, with a source region capable of surging cold air north into Brazil and threatening the coffee-growing regions. By the middle of July, the same wave train had swung phase, and forecast guidance was calling for record warmth centered on Paraguay and the surrounding area. Salta's record warm night on the 18th of July sits inside that flip. This is the part people find hardest to accept, so it is worth being concrete about it. Nobody is claiming that cold air from Antarctica traveled to Argentina and arrived warm. That is not the mechanism. What travels is the shape of the atmosphere. A vortex anchored in one position bends the jet stream into a particular set of ridges and troughs downstream of it, and those ridges and troughs determine which air masses end up sitting over which countries. Put the trough in one place, and northern Argentina imports polar air. Let the pattern shift by a few hundred kilometers, or swing to the opposite phase, and the same country instead imports tropical air out of the continental interior, and does it in July, when the sun is providing almost no help. The vortex does not deliver the temperature. It arranges the plumbing that decides where the temperature comes from. So the framing you may have seen, record cold over here, record heat over there, isn't the planet strange, is not quite right. It is tighter than that, and less comforting. A single, unusually intense polar vortex bottled extreme cold over the Antarctic plateau while simultaneously organizing the wave pattern that delivered record heat to subtropical South America. One machine, two opposite outputs, same date. Now I want to close off something that started circulating within hours of the Concordia figure appearing, because it is the single most common misreading of this event, and it needs one clean paragraph rather than a whole segment. The claim is that a record cold reading proves the warming narrative is false. Here is the arithmetic. The coldest temperature ever reliably recorded on Earth is minus 89.2 degrees Celsius at Vortex Station in Antarctica. That was set on the 21st of July, 1983, the anniversary of which fell yesterday, 43 years later. Saturday's reading of minus 84.1 is 5.1 degrees Celsius warmer than that mark. A cold record that fails to beat a 43-year-old benchmark by more than 5 degrees is not evidence of a cooling planet. And coldest since 2012 is a 14-year statement about one station sitting in polar night. It is not a global statement. In the same year this reading occurred, more than 100 countries set heat records. The world's oceans had their hottest June ever measured, averaging 20.98 degrees Celsius. A European heatwave in late June was associated with more than 10,000 excess deaths. And the total spread between the hottest and coldest points measured on Earth this year, 52.7 degrees Celsius at Omidyar, Iran, against minus 84.1 at Concordia, comes to 136.8 degrees. That is a wider range than the entire gap between the freezing and boiling points of water. There is one legitimate kernel in the complaint, and I will concede it. Cold records genuinely do still happen in a warming world, and coverage that implies otherwise is bad science communication. People notice when only one direction of record gets reported. That frustration is fair. The conclusion drawn from it is not. Two related claims handled quickly. That agencies hide cold data. The Concordia figure came from the monitoring network itself and was publicly reported within about a day, and that the event was engineered. The Antarctic polar vortex is a hemispheric scale circulation feature driven by the temperature gradient between the equator and the pole, and by planetary wave activity originating thousands of kilometers away over the tropical ocean. Nothing anyone has built operates at that scale, or anywhere near it. So the lid held this year, and the plateau got cold, which raises the obvious question: what happens when it does not hold? We do not have to speculate, because it happened 24 months ago, and there is now a peer-reviewed paper on exactly what followed. In July and August of 2024, East Antarctica experienced the most intense winter heat wave in the 46-year satellite era. Across a region called Dronning Maudland, average surface air temperatures ran more than 9 degrees Celsius above the climatological mean for 17 consecutive days. The peak values are harder to absorb. In central Dronning Maudland, near-surface temperature anomalies reached up to 27.5 degrees Celsius on the 5th of August. At two individual research stations, Relay and Dome Fuji, anomalies peaked at 30.1 and 30.9 degrees respectively, both on the same day, 30 degrees Celsius above normal, over Antarctica in winter. The estimated return period for that event was approximately 1 in 135 years. In the ERA5 reanalysis record, the regional temperature and precipitation extremes exceeded 3 and 4 standard deviations, respectively, and the trigger was precisely what you would expect from the lid model. The event coincided with the earliest sudden stratospheric warming ever recorded in the southern hemisphere since satellite monitoring began in 1979. Two successive warming events in early July of that year raised mid-stratospheric temperatures and left the vortex weakened and displaced. The wave activity that did it was measured directly. At the 10 hectopascal level in the stratosphere, across the band from 45 to 75 degrees south, the eddy heat flux anomaly exceeded 4 standard deviations, and it was dominated by the largest and simplest wave pattern the atmosphere can make, a single wave wrapping the hemisphere. Researchers traced the source of that wave activity back to enhanced thunderstorm activity east of Australia and to wave trains propagating poleward from South America and the subtropical Atlantic. In other words, the thing that broke the lid over Antarctica was weather happening thousands of kilometers away, in the tropics and mid-latitudes, pushing upward and southward until the vortex could not absorb it any longer. The lid came off, and the continent that had been the coldest place on Earth ran 30 degrees hot. The paper is titled Unprecedented 2024 East Antarctic Winter Heat Wave, driven by polar vortex weakening and amplified by anthropogenic warming. It appeared in NPJ's Climate and Atmospheric Science in April of this year, led by Hao Su Tang and Sihan Li. A few of its findings are worth your attention. On mechanism, The weakening of this stratospheric polar vortex initiated a high-pressure anomaly that enhanced the transport of heat and moisture toward the pole, and that circulation accounted for roughly half of the observed surface warming. Large-scale circulation alone accounts for 47% of the total anomaly, with an uncertainty range from 27 to 66%. On what carried the heat, enhanced moisture transport, likely helped along by a series of atmospheric rivers, raised humidity and cloud cover in the lower atmosphere and strengthened the downward flow of long-wave radiation. The authors call it a water vapor, cloud and radiation feedback. On human influence, the authors estimate that anthropogenic warming intensified the event by approximately 0.7 degrees Celsius and more than doubled the likelihood of that class of winter heat wave in the present climate. Their framing is worth quoting closely. What would have been a multi-century event under natural forcing has become a centennial-scale event today. And on where this goes, compared with a climate without human influence, the likelihood of these events rises from 2 to 3 times today, to roughly 6 times under moderate emissions, and up to 26 times under high emissions by the year 2100. The authors are also careful in ways that deserve repeating. Several of their uncertainty ranges cross zero. They found no robust trend in the frequency of the circulation pattern itself. And they note that, although the event produced record-breaking anomalies, most surface temperatures still remained well below the melting point. Hold on to that last sentence. It is about to become the whole point. Because there is a second Antarctic temperature record from this winter, and it did not get the coverage the cold reading did. On the 6th of June, Esperanza Base, on the northern tip of the Trinity Peninsula, on the Antarctic Peninsula, observed a winter record of 15.4 degrees Celsius. Other research stations in the same region logged similar record warmth. For nearly 3 straight weeks, daily maximum temperatures in that region stayed above freezing. Not near freezing, above it for weeks in the middle of the Antarctic winter. The result was extreme melting. At the mountain bases of the Collins Glacier, bare ground appeared. Bare ground is not a poetic detail. It is a physical change in how the surface handles energy. Snow and ice reflect most of the sunlight that reaches them. Exposed rock and soil absorb it, warm up, and then radiate that heat into the snow and ice still sitting next to them. Once a patch opens, it tends to widen, and it does so faster than the temperature alone would suggest. On the peninsula in June, that process started in the middle of winter, the season when the surface is supposed to be gaining mass, not losing it. I want to be clear about the significance here, because it is easy to file this as another record on a long list. That happened on the same continent in the same winter as the minus 84.1 reading. One landmass produced the coldest temperature on the planet, and a midwinter melt event within weeks of each other. So return to the restraint the 2024 authors wrote into their own paper. Even during the most intense winter heat wave in the satellite record, most surface temperatures remained well below the melting point. That is true, and it is the correct thing to say about the plateau. On the high, dry interior, a 30-degree anomaly takes you from something like minus 60 to something like minus 30. That is a spectacular number on a chart. It does not melt anything. On the peninsula this June, temperatures did cross the melting point, and they stayed across it for almost 3 weeks. That is the distinction that matters, and it reframes the entire question. A vortex breakdown over the interior plateau produces a temperature record. A vortex breakdown positioned over the coastal ice, the ice that is actually in contact with the ocean, the ice that buttresses what sits behind it, produces something else entirely. The honest version of the argument is not that Antarctica is warming and therefore records fall. It is narrower and, I would argue, more unsettling. Antarctica's variance is becoming the story. The local warming trend in that region runs at half a degree per decade. The likelihood of these breakdown events has already roughly doubled from human forcing, but the frequency of the circulation pattern itself shows no robust trend. The swings are not obviously happening more often. The background they swing against has shifted, so when one happens, it lands further out than it used to. Here is where this stands as of today, and what is worth tracking. The vortex is still the variable. The Antarctic Oscillation is the index to watch, and it is published continuously. When it is strongly positive, the plateau cools, and the wave train reorganizes the South American pattern. When it collapses, the reverse. Sudden stratospheric warming events in the southern hemisphere are rare, and the 2024 pair arrived earlier than any on record, so timing alone is now part of the signal. On sea ice, one honest note, Antarctic sea ice reached its annual minimum on the 26th of February this year at 2.58 million square kilometers, 16th lowest in the 48-year satellite record, and a partial recovery after 4 consecutive severe years, though still well below the long-term average. The July growth season is again tracking low, That is a mixed picture, and anyone selling you a collapse narrative from this year's numbers is going past what the data supports. And on the sun, one line, because the question always comes, solar activity this month was moderate and declining, with a sunspot number of 94.4 and quiet geomagnetic conditions on the day these records were set. There is no mechanism by which the state of the sun produces an Antarctic Oscillation of +5 and a record warm night in Argentina on the same afternoon. This one closes easily. What I would keep an eye on is the coast. The machinery has now demonstrated, inside a 24-month window, that it can lock tight and produce the coldest reading on the planet in 14 years, and that it can fail and produce the largest winter warm anomalies ever measured over that continent. Both outputs come from the same structure. The background it operates against is warming. And the models say these breakdown events become up to 26 times more likely by the end of this century. The question is not which record matters more. It is what happens the first time a breakdown of that magnitude parks itself over coastal ice rather than the interior plateau, and whether we would recognize the difference while it was happening. We will be tracking it.